This video is sponsored by Brilliant. In this video, we're going to learn polars from scratch. This video is good for those who already know pandas and want to explore polars in Python. We'll cover topics like polars, lazy mode, attributes and methods, learn the expression API, and more. So let's get started. Okay, let's start by analyzing the two evaluation modes that polars support, lazy and eager mode. And first, let's start with eager mode. We use eager mode in polars by using the read_CSV method. This creates a data frame as soon as we run the command. And well, this is immediately executed. And let's first import polars. So import polars as PL. And well, in case you still don't have polars installed on your computer, what you have to do is open a new cell and then write !pip install and then polars. And with this, you're going to install polars on your computer. Okay, let's start with the eager mode and let's use read_CSV to use the eager mode in polars. So first, let's write PL and then read_CSV. And this is similar to what we do in pandas. This is the similar method that we use in pandas. And here we're going to use a dataset that I'm going to leave on the description. And this is going to be a dataset called student performance.csv. This is the dataset that we're going to use. Then I type equal to, and this is going to be a df_eager. So when we use pandas, we use the read_CSV method, and by default, pandas is going to use the eager mode. And well, if we use the read_CSV method in polars, we're going to use the eager mode and we're going to create a data frame immediately. And this data frame is going to be called df_eager. So now I run this, and as I said before, as soon as we run the command, as soon as we run this code, the data frame is created immediately. So now here I can type df_eager.head, and with this we're going to see the first 5 rows of this data frame. And here we got the columns, and we don't get the indexes because in polars we don't have indexes like in pandas. And also we got the type of the column here, string, and well, then we have integers in the last 3 columns. And this is the eager mode in polars, but we're not going to use so much the eager mode in polars. What we're going to be using often is the lazy mode. And we use lazy mode in polars by using the scan_CSV method. In lazy mode, operations are not immediately executed. Instead, they are recorded and only evaluated when necessary. This allows polars to create a logical plan and optimize it before actual computation. Alright, now let's use the scan_CSV method to create a lazy frame. We create lazy frames when we are in lazy mode. So first I type PL and then I use scan_CSV. Then I open parentheses and we're going to use the same data frame, the same dataset. In this case, student_performance.csv. And well, I'm going to name this as df_lazy. And this is going to be my lazy frame. First, we created an eager frame because we were in eager mode. And now we are in lazy mode because we're using a scan_CSV, and we're going to get a lazy frame. So now if I print this df_lazy, we're going to get this plan. And this is a logical plan that we get when we create a lazy frame. And this plan is read from bottom to top. And in each line, you can see the steps that are followed in this plan. So for example, first you see project, then 8 columns. So this dataset has 8 columns, and well, it recognizes that it has 8 columns. Then we see CSV scan student performance.csv, and this is the name of the dataset, and here is reading this dataset using scan_CSV. And so far, these are the only 2 steps that are included in this plan. And then we can see this naive plan. Then we see a round lazy frame that describe_optimize_plan to see the optimized plan. And this is a method that we use to see the optimized plan. And well, as you might remember, Polars creates a logical plan. Right now we have the logical plan, and later this logical plan is optimized. And well, this is optimized before the actual computation. And if we want to see the optimized plan, we have to use this method. Alright, now let's see some attributes that we can use in Polars and how methods work in lazy mode. Alright, first let's explore the attributes that we can use in Polars. And if you know pandas, you're in luck, because some attributes that work in pandas, you can also use it in Polars. So let's explore some of them, some attributes that pandas and Polars have in common. So first, I'm going to copy the data frame that I created before, which is df_lazy. And what I'm going to do is use the first attribute, and this is going to be columns. So if I press tab, I can complete this method, and I have here df_lazy.columns. Now I run this, and here we can see the columns that this data frame has. So we can see that there are 8 columns. And this is the first attribute. This attribute is possible to use with Polars and well, also with pandas. And now let's analyze another, which is scheme. And I'm going to type df_lazy.scheme, or sorry, schema. And if I run this, we're going to see that we get the name of the column. On the left, this is a dictionary, so we have a key and a value, and as the key, we have the name of the column. And as the value on the right, we have the type of this column. So we can see UTF-8 and we can see int64. So those are the types of the data types of each column. And that's what we get with the schema. We get a dictionary with a pair of key and value. And in the key, we have the name of the column, and in the value, we have the data type. Now, there are some attributes that we can use in pandas that are not possible to use in Polars. For example, there is shape that we can use in pandas to get the number of rows and number of columns, but that's not available. We cannot use that in Polars, because in Polars, when we're in lazy mode, we don't know the number of rows that a data set has. We only know the number of columns. And well, that's also in the plan, in the logical plan. We see here 8 columns, but it doesn't say anything about the rows. And we can verify this by trying to use the shape attribute. So I type here df_lazy and then that and then shape. We run this and we get an attribute error. And this happens because Polars doesn't know how many rows we have in a data frame. And well, we cannot use shape in this case in Polars. Now let's examine how methods work in lazy mode. And this is a bit different from eager mode, and I'm going to show you here. First, I'm going to use the data frame that we created before in eager mode. So it's df_eager. So I'm going to paste this data frame here, and I'm going to apply a common method that we use when cleaning data, and this one is drop. So I want to drop a column. Let's say I want to drop the gender column. So I'm going to copy this name of this column, open quotes, gender. And now I press enter, I run this cell, and I got this data frame. So as soon as we run this method, we get the operation. The operation is executed immediately, and we get this data frame. And in this data frame, we see that there is no gender column because it was dropped. So this is how things work in eager mode. But in lazy mode, it's different. So let's now use this same method in lazy mode. So here I'm going to copy the name of the lazy data frame. I'm going to minimize this, and I'm going to paste here df_lazy. And now let's use the same method. And actually, I'm going to copy this, that drop, and then gender, but now with the lazy frame. So here I'm going to run this, and we get the logical plan. So instead of getting the data frame right away and executing the operation, we only added a new step to our logical plan. So here you can see we have project 8 columns, then CSV scan, and the name of the dataset, and we have a new step, which is drop. And this is the method that we apply to our data frame. So instead of executing this method immediately to our data frame. Here we only added this to our logical plan. And this is good because later Polars is going to optimize this logical plan. And this is good when working with large data sets because this improves speed and performance. Alright, so far we learned to use some common Polars methods, which is good. But as a data analyst, you should also develop your analytical thinking. And that's something you can do with today's sponsor, Brilliant.org. Brilliant is the best way to learn math, data science, and computer science interactively. Lately, I've been using Brilliant to brush up on my math because I needed to understand the tech side of AI. And my favorite part about Brilliant is that you can learn new subjects interactively. For example, if I want proof why the angle sum of a triangle will always be equal to 180, I could use Brilliant to play with the actual triangle and find out that the fact holds no matter the shape of the triangle. This helps develop your analytical thinking, and it's more fun than reading a textbook. The same goes if you're learning how to code. It helps your brain more to see what your lines of code produce in a simulation, and that's what you get with Brilliant. Brilliant has helped me develop my analytical thinking, and this is better than memorizing math formulas and equations, and it's necessary if you want to survive in that new AI age, where tools like ChatGPT are getting better at solving math problems and writing code. To try everything Brilliant has to offer free for a full 30 days, visit brilliant.org/thepiecoach. The first 200 of you will get 20% off Brilliant annual premium subscription. Thank you Brilliant for sponsoring this video, and now let's go back to the video. Alright, now let's see how to select columns in Polars. And well, in Polars we can use the select method to select columns. And this is as easy as typing the name of your data frame, in this case the lazy data frame that we created before, and then typing that select. And inside parentheses we have to type that column that we want to select. In this case we want to select, let's see the data frame, and we want to select, let's say, math score, this column. So here I'm going to type quotes, then math score. And now if I run this, we get again the logical plan, and in this logical plan one new step was added, and this is the select from. And well, we are selecting this column from our data frame or from our data set, and this is what we get when using the select method in lazy mode. Alright, this is a straightforward way to select a column, but there is another way that is used more often because it allows us to apply operations to a column and build complex expressions. And this is using pl.call. And I'm going to show you how this works. So first I'm going to copy this and I'm going to paste it here. So instead of typing the name of the column right away, what we have to do is type pl.call, and inside parentheses we have to type the name of the column. So in this case, math score. And this is the syntax that we have to use. Now if we run this cell, we get the same plan, the same logical plan. But the difference is that now we can apply operations to this column. For example, here we have numbers. This is an integer column. And now if I type +1, now we can add 1 to the numbers that are in this column. So here I run this, and as you can see, we add +1 in this logical plan. And it's not possible to do this in the previous example. If I type +1 here, we're gonna get an error. If I try to put this inside parentheses, we still get an error. And that's why this second option, using pl.call, it's more commonly used. And now you might be wondering, okay, I just did an operation to this lazy frame and I have this in the logical plan. But what if I want to see how the operation is applied into the actual data frame? Well, every time that you want to see anything that is in the data frame and not only see the logical plan, what you have to do is use the collect method to display the lazy frame. And I'm going to show you how to do it. So first, I'm going to type the name of the lazy frame, in this case df_lazy. And actually, I'm going to just copy all of this because we're gonna use the whole expression. And here I'm gonna add that collect and then parentheses. And with this, we're gonna display the whole data frame. In this case, we only get the math score column because this is the column that we're selecting. And well, we get the math score column plus 1. And here we have 73. Before it was 72. And as you can see, it was added 1 unit to each column. So whenever you want to execute the lazy operation and return the actual data frame, use the collect method. And remember, in lazy evaluation, the operations on a data frame build a logical plan that don't get executed immediately. That said, the operations are executed when you call the collect method. Alright, now let's see something that we've been using so far without being completely aware of it. And this is the expression API. The expression API in Polars is designed for lazy evaluation. Instead of executing operations immediately when called, which happens in eager evaluation, when we use the expression API, we will build a logical plan of operations that will be executed later when we explicitly request it. For example, when we use the collect method. The advantage of this approach is that it offers opportunities for optimization, potentially speeding up the overall computation. The expression API encourages a method chaining approach, which can lead to a cleaner and more readable code, especially when performing a series of transformations on a data frame. Alright, now let's rewrite the previous code we created to visually separate each operation, making the code flow easier to follow. And I'm talking about this code that we created before. So here we're using many methods, and we're using also the chaining approach. So we're applying different methods into this single line of code. But now let's rewrite it. And let's do this in the second cell. So first what we have to do is open this parentheses. Then I'm gonna type df_lazy, and then what I'm gonna do is press enter and then type one method in one line. So first I have the select method, and then I'm gonna paste this pl.call, and then I'm gonna press again enter and then collect. So this is the same code, and this is gonna get the same result, but now this is more readable, and this is recommended to use because this improves readability. And in Polars we will be using multiple methods to create our logical plan. Okay, now let's run this, and we get the same result. We get the math score, and we get this with the 1 unit added to each value in the math score. And well, this is the expression API. Here, as you can see, we're building our logical plan of operations that will be executed later. And we can see the plan if we delete the collect method. And this is what we'll be using often in Polars. Alright, now let's apply what we learned so far and calculate the mean of the math score column and also the mean of the reading score column. And then sum the values of each column. And for this, we're going to use different things that we learned so far. For example, we're going to select columns, then we're going to apply some methods, then we're going to use pl.call, and finally, to display all of this, we're going to use that collect method. So let's do this. First, what I'm going to do is here type df_lazy because this is the column that we're gonna use. And by the way, we're going to use the expression API from now on. So here I open parentheses, then df_lazy, and let's use the first method, which is that select. So we're going to select 3 or actually 2 columns, math score and reading score. So here I press enter to open these parentheses, and now let's continue with the first column, the math score column. So to select, I'm going to use pl.call and then inside math score. And well, now I have this column selected, and what I'm going to do here is use the mean method because, as I said before, I want to calculate the mean of this column. And now let's give a name to this new column. So after applying a method, this is going to be a new column, and we're going to give a name to this. And to give names to a column in Polars, what we have to use is the alias method. So I type alias, and then I type the name that I want for this column. In this case, it's gonna be mean math score. So with this, everything is set for my first operation. And this expression should be inside parentheses. So I'm gonna type parentheses, and this is my first column. So we're making operations, and we're gonna create something like a new data frame with these operations. So my first column is this. Then second column, I open parentheses, and I'm going to calculate the mean of the reading score column. So here I copy and paste the previous expression I had, and instead of math score, I type reading score. Then again, I'm gonna give an alias to this column, and in this case, it's gonna be mean reading score column. So here I delete and I type reading score. And finally, the last column is gonna be the sum of these two operations. So the sum of the mean in the math score column and the sum of the mean in the reading score column. And before I do this, I have to add here the comma, because we're separating this first column to the second column, and then the second column to the third column. And here I'm going to paste the reading score column, and then I'm gonna copy pl.col math score column, that means. So here I type this, and between these two I type plus. And with this, we're gonna sum the mean of the math score column and the reading score column. And finally, I'm gonna give an alias to this third column. So here I type that alias, and the name of this column is gonna be total score. So with this, everything is ready, and here I can run this, and we get the naive plan because we're using a lazy frame. And as you can see, we have first the name, the number of columns, then the name of the dataset, and finally the select from. And now if we want to display the actual data frame, what we have to do is type collect and then parentheses. And that's it. We get our data frame. First we have the mean math score column, then the mean reading score column, and then finally the total score column. And then we have the value of each column, and this comes from the operations that we applied before. And that's how we do operations in Polars. We'll be using a lot the expression API to apply multiple methods and operations, and still keeping the readability in our code. And that's it for this video. Let me know in the comment section what other things you would like to learn in Polars. And I'll see you in the next video.